So this is problem 102. We have to find the enthalpy of reaction here. And so we've got the enthalpies of formation from Appendix C. Subtract reactants from products, and you get negative 353.0 kilojoules per mole of magnesium. And that's part A. Part B, this reaction's happening. We've got some data. We have 75 milliliters of water. We're going to assume that's 75 grams of our solution. We're going to assume that the specific heat is 4.18 joules per gram degree Celsius. We can calculate delta T, final minus initial. We get 58 degrees Celsius there. I'm going to plug those values into our equation, Q equals mc delta T, and we'll get the enthalpy, the reaction, when 75 grams of water is heated up to 58 degrees Celsius, or by 58 degrees Celsius, excuse me. And so remember, the Q that you calculate here is the Q for the calorimeter, right? The Q of the solution, which is 18,183 joules. You need to make sure that you flip the sign on that because you're interested in the heat of the reaction, which is negative 1,183 joules, or 18.183 kilojoules. Now we've got a little stoichiometry to do. We want to find the number of grams of magnesium that will produce that much heat. Well, in part A, we found out that 1 mole of magnesium produces 353 kilojoules. Well, now we've got a much smaller number, so we're going to use that ratio from the first part. 1 mole of magnesium for every 353 kilojoules of heat released. We're going to use the molar mass. And we've got our calculation here, and out we're going to get 1.25 grams of magnesium needed.